Hello, in this video we are going to talk about hypothesis testing, and previously we have gone through what is hypothesis testing, a z-test, three types of t-test, and right now we have also done one-way ANOVA test, and now we are going to look into two-way ANOVA test. And two-way ANOVA test is when you are comparing three or more data sets depending upon not just one independent variable but two independent variable. We'll get to an example and we'll be pretty much be able to understand what do I mean by that. So let's say we are going to compare scores, and we are going to see based on two independent variables. So here the dependent variable is test scores, which is a continuous value, and two independent variables, which are the method of teaching and the gender that is going to be considered. So let's get into the example and it'll be much more clear when we do this. We are going to use stats model. Stats models formula both ordinary least square, and this is going to be our data. We are going to convert into a data frame and we are going to pass the values. So let me just quickly, so yeah, these are the values, and let me just make it much more easier. Mm, so this is basically a yes, is there something wrong? Okay. Mm, now it should work. Let's see. Yeah, so basically what is happening here is we have different scores and we have different methods and we have gender, female and male. So each will be like, its own data, one, two, and three different data sets. And you can see the score is dependent on two independent variables, which is the method of teaching ABC and the gender male and female. So let's fit the model. Yeah, so we are going to fit the model and we are going to make the table. Stats, Anova, so model, and it's basically type 2 Anova, and let's call the table. So yeah, you can see that this would be our p-values, and the parameter goes in such a way we set alpha value to be 0.05, and if ANOVA table of P of R of, if either method or gender If either of them, or even the fact that method to gender ratio, if any of them has a p-value less than 0.05, then we're going to reject the null hypothesis. Less than alpha, or even if it's less than the method to gender, we are going to reject the null hypothesis. And to copy it from here. Yeah, so it's going to get rejected because you can see that its value here is less than 0.05, so which is why we're rejecting it. If either one of them has a p-value which is 0. Less than 0.05, we're going to reject the null hypothesis and accept the alternate hypothesis. So there is a significant difference between the method and the gender. Especially you can see that with respect to the method, there is a, if the method is different and there is an impact with score. So yeah, this is pretty much it in a real-time scenario.